All right, so here are your two questions that you're going to be faced with in just a second. I'll give you a better format for them, so don't try to save them or anything. So what's the deal with your questions? One on the left is, if you'll notice, this is so special. They couldn't come up with a bad enough question for you, so they went all the way to the Physics 1 exam, right? The problems are so bad in Physics 1 exam, we talked about that last year, you really can't tell a kid knows any physics or not. Well, here you are. They went to the Physics 1 to get one of your two questions. And by the way, you're thinking, well, Mr. Redden, what about the classical mechanics and E&M? They actually use the same example questions for both your classical mechanics and your E&M. So this is the examples for both tests, okay? So they think the one on the left is the first one they give you. They're going to give you 25 minutes to do it, just like you would if you were taking a Physics 1 class. And this is what they call the qualitative quantitative problem. Now, the qualitative quantitative problem is as follows. You usually get two students. They're usually both doing bad physics. And so what they're going to ask you is they're going to say, look, explain to us how student A is right. Now, the first thing your instinct is going to be student A is not right, but focus on the part that's important. The part that's important is where are they right? So you're going to have to figure out where they're correct. Okay? And then they're going to say, student B is incorrect. Tell us how student B is incorrect. Now notice they're saying the words tell us. The word you're going to be looking for is qualitative reasoning. Qualitative reasoning. We see the word qualitative reasoning. It means use words. I don't want to see an equation anywhere on this piece of paper. No matter how much physics you learn, no matter how the physics explains with numbers and with letters and formulas, you cannot use them. Please don't use them. Please just explain to us why this is physically going to happen. Okay? Why physically they're right or physically they're wrong. Then what they're going to do, they're going to take a pause, and then they're going to ask the same questions again, except the second time around they're going to say quantitatively, which implies numbers, but they don't mean numbers, they mean equations. And so they're going to say, okay, now prove to us if student A is wrong using quantitative reasoning, which means using the equations. Show us how the equations don't work. And then they'll go back to maybe student B and say, tell us why he's right, what he's right about in terms of quantitative reasoning, okay, in terms of equations, okay? So again, things to watch out for in this type of question. One, don't argue with the question. If the question says that student A is right in some fashion, figure out how student A is right in some fashion. Get that on the paper, okay? You may disagree down to your toes about what student A is saying, but it doesn't matter. There's something right in there. They said so. Find it, okay? No matter how crazy it may seem. Use qualitative reasoning when you're talking about, so you're going to use words. When they ask for that, they want qualitative. They want just words. No equations. No. Now, if you have to slip an equation in there to explain your reasoning, you can. But it should be the last resort. Okay? It should be the last resort. There's a chance they will take away your points because of it. Also, be aware, almost always this problem is going to feature some bad physics. Lots of bad physics. Therefore, ignore the fact it's bad physics, listen to the question, and answer accordingly. You're going to have 25 minutes to answer this question, and you don't need 25 minutes. You probably need about 15. So therefore, take your time, read the question, sense what it is they're actually asking, right? Sense what they're actually thinking, okay, about this question, all right? All right, then you're, so that's the first question they're going to throw at you, and it'll be on that day, it'll be 25 minutes. The second question they're going to throw at you is singularly the worst problem they've ever asked in AP Physics C history. Yes, it's that bad. So over here on the right-hand side, I have the second question. You are to perform an experiment. This is the one time since 1961 on the AP Physics exam, they said, we're just going to ask you to do a lab the whole entire time. There's absolutely no equations, physics, anything in this equation problem. It is purely, do you know how to do a lab? Okay, so listen to me carefully. The reason why I make you do those little labs we're doing, the little mini labs we do in class, is this moment here. I want you to think in terms of drawing a picture like we did in class. How do you show your measurements? Okay, Make sure you diagram the measuring equipment the way you're supposed to. Do not spend hours on shading behind the equipment. You don't have that kind of time, and it doesn't have to be beautiful. Okay? If you drew something weird looking and you're sure they don't know that's a stopwatch, draw an arrow to it and write the word stopwatch, and that'll take care of it. Okay? All right. When you get done, there's going to be questions at the end that are basically lab questions. They're going to be the questions that I asked you in the past, mostly in Physics 1. And they're questions like, hey, what do you think happened here? And so they're going to say, something strange happened in the lab. Like you're trying to conserve momentum, and you discover that at the end of the experiment, you had a lot more momentum than you started with. Explain what could have happened. Okay? Those sorts of things. You know, things that happen in real life labs when you get done with the measurements and the calculations and you're all the way done, you realize that something weird happened here because this did not work out the way it was supposed to. Okay? They're going to ask you questions. Think physically. Think what could have happened inside the lab that could have caused this to happen. Do not argue with the question. They're saying the data says that. Your job is to go, okay, so if I was in the lab and this really happened, what would happen? Also argue that sometimes when we're trying to explain what happened in the lab, you say things like, so-and-so released the thing wrong. He pushed it, whatever. Don't go there. Instead go, it may have gotten a push. It may have gotten a shove. It may have been dropped. The measurements, because of the way it enters the equipment, might not have triggered at the right time. You know, whatever that is. You know, talk about what could have happened in a real lab. Okay, because the sole purpose of MEC 2, that second question that's on the right-hand side, that sole purpose of that question is to know if you've ever done a lab before. As long as you answer the question, I have done the lab before, as long as they understand, hey, things like I'd have to tape that down with duct tape, you know, draw duct tape strips, taping. When they see that, they're like, here's a kid who's done a lab. They know you've done a lab, and they're trying to give away points. So what they're trying to give away points for is, have you ever done a lab before? And so that's what it is. So think about that. Make sure your diagrams the way we did them in class, and you should be good to go. So I'm going to now ask you to do the example problem. I'm going to ask you to do MEC 2 in just a second. I've got it attached in there later on the Teams thing. I've got an answer key for you afterwards. The answer key has 3 sample problems. I want you to look at them, okay? And then I want you to read my notes afterwards on what I think you likely did, okay? Now, here's the problem with MEC 2 in particular, okay? MEC 2 is the only problem like it there is. I'm going to find you problems that are similar, that are partials, but it's only one like it ever. Okay, so there's never going, I can't give you another example of this type of problem because it just doesn't exist. Okay, and so what I'm going to try to do here is I'm going to give you pieces later on. But this is the problem. This is it. So you need to look this one over. You need to look at those example problems, and you need to read those notes at the end. If they still don't, you're like, I'm not comfortable with this question. Send me questions. Send me thoughts. We can talk about as much or little as you want. Okay. All right. All right. Have at. Try MEC number 2. But before we get done here, afterwards, I'm going to ask you to do MEC number 3. The one that's on the left. It's the second one. It's the first question. It's going to be a second one I ask you to do, and I have me doing that problem because I think that's helpful. I don't have me videoly doing MEC 2 because your answer could be anything. Like you're making up your own lab. I don't know what you made up, so you know you're going to have to read the key. You're going to have to read the example problems and figure out what you want to do, what your strategy is going to be for this one. Okay. All right. With that in mind, you're hereby go ahead and do MEC 2. When you're done with that, read my notes. Then do read the samples. Then on MEC 2, read my notes. Then go to MEC 3, do the second one that's on there. Try out that problem, and then read the key, and then watch me do it. All right, and that's it for today. All right.